Cool. Again, my name is Dave Boucha. I work for SaltStack, and I'm really excited about this talk. It's a fun one for me. It's kind of a crazy stuff you would never do in production or in real life, but kind of give you an idea of, a greater vision of possibilities of things you can do with Salt. So, who here has used Salt either in a testing or production environment? Okay, so about 80% of us probably. Grumpy guy's shaking his head. Yeah, he does. Okay, so I'm going to just talk a little about some of the very basics, some of the general use cases of Salt that people use Salt for. And then I'm going to talk about some of the other pieces of Salt that people often kind of miss when they think of config management. They don't realize there's so much more to Salt than just that. And I have a couple demos that will be interesting. And so get to use your cell phone if you have a cell phone signal down here. Mine it doesn't, unfortunately, but we'll be able to. Everybody will get a chance to participate. So beyond config management. All right. So Salt basics. There's generally you would use Salt with running a Salt master that controls other servers that are running an agent called the Salt minion. If you have a situation where you don't need a constant connection to your servers, you can use Salt SSH to have Salt work across SSH in a like one time or not have that constant connection all the time, but just go over to SSH when needed. So this is kind of what they typically would look like. So you have your Salt master, you have a couple of minions here connecting through ZRMQ, and then also Salt master reaching out to one server through SSH. If you'll notice, the arrows are pointing from the minions up to the master, because when you're using ZRMQ, Salt uses a pub/sub interface, and the minions actually connect to the master. So the master needs to have two ports open for the minions to connect to, and the minions listen on that publish port. Whereas when you're using SSH, Salt master does reach out to your minions and does things. When you're using ZRMQ in this pub/sub interface, that allows Salt to scale into the tens of thousands of servers because the master doesn't have to, specifically manage every server that's connecting to. So that's why it's done like that. You can also use the Salt minion by itself, so with no master at all, so everything's just done locally. Sometimes I'll do that on my laptop. I don't want, sometimes I'll have a master and a minion running on my laptop, but other times I'll just use the minion by itself to configure my laptop. People do that in production as well. If for some reason they can't or don't need a Salt master, they'll just use the Salt minion by itself and do all the configurations locally. They'll pull them down from like S3 or other locations. A syndic allows you to have hierarchies of masters. So you could have a top-level master that can see everything in your entire infrastructure, but then maybe you have a lower-level master in different data centers, or maybe different business groups have their own master down below, and that allows you to have kind of a high-level view from this top master, but lower-level control down below. It also helps with scaling as well. Minions can also talk to multiple masters. So you can have a multi-master situation where they'll accept commands from masters. Some people use that for a kind of poor man's failover type thing for your master, or also for different people needing control or visibility into your servers. So advanced Salt features. One of the things that really differentiates Salt from others in this space is that fast, encrypted, dynamic connection that your servers have between the master and the minion. So we have an event bus that runs locally on the minions and also runs from minions up to your master. So events, things that happen on your Salt infrastructure get passed up to the master for various purposes. Salt itself sends lots of events, so when a minion starts up, when a new minion tries to connect to the master, there'll be an event. There's a whole variety of things that would cause an event to be sent up to the master. You can also send your own events. So you can have your own application send an event to the Salt master. There's a whole variety of things you can do with that. One of those things is a beacon. So a beacon is a small service that will run on your minion that will monitor something. So we have beacons that'll monitor your file system, that will monitor your SSH logins, a whole variety of things. And we'll be talking about a Twilio beacon that monitors a Twilio text message queue and then send an event on the event bus. Reactors and engines. So the Reactor sits on your Salt master, and it sits there and listens to that event bus and allows you to do things, react to those events. So maybe there's that one stupid application you have to manage that needs to be rebooted every time it hits a certain memory level. Maybe you can check for that, and instead of having to manually go in and do that yourself, an event gets sent up to the master saying, hey, this dumb application needs to be restarted, and then the Reactor sees that event, restarts your application, and moves on, logs it somewhere, and barely a hiccup. Just a simple example. And engines are similar to that. They're a Python interface, so you can create your own little programs that will listen to that event bus and do things in Python. So there's a little more flexibility there in your Python. Tonight we'll also use a Salt API. You can turn on a REST interface that allows you to reach out to Salt from any other application and do things with that. So if you have an existing CMDB, an existing application that manages things on your network, now Salt's all the possibilities of Salt are now available to your application. So you have a Python interface as well as this REST API, and really makes for some really interesting use cases there. So again, we'll demo that a little bit today as well. So again, it's just kind of like an overview. You have a minion here, beacons and engines run on the minions, reactors, engines as well, and the API run on your Salt master. Okay, now we're going to do live demos. So, yes. All right. I had to rebuild the server last night to make sure everything works smoothly. So, so you see here, what's that? Yeah, exactly. All right, so you're probably all, I think after 4 years I would remember that. Okay, so I have a master, I have one minion that I'm controlling here, and most of you are probably familiar, we have this whole slew of modules that you can run. So on all my minions, I'm going to run disk.usage. We're going to get that data back, almost instantly. Yeah, do we have, actually I could probably increase the, better? All right. This is how we work at Salt anyways. Over in the engineer section, all the lights are off like this. So you can see, you can also get that data back in different formats. So say I want that in JSON so I can ingest that with some other tool. There's that exact same command, output it in JSON. You can get it in raw text, in the raw Python data structures that it comes back in. Everything in Salt is a data structure, so that allows you to do a whole variety of things, including manage the output like this. You can also do command.run will allow you to run any arbitrary command on your systems here. And that was one of the things that got me really excited about Salt originally when I first found out about it, was just I felt like I had this power. I mean, finally I could reach out and know what's going on the servers on my infrastructure. What's the disk space looking like? There's this one server that we're constantly checking, we have monitoring, but what's going on right now? You can run these commands, get that data back, and do something with that really, really fast. In fact, the remote execution was built first. When Salt was first written, it was just all it was remote execution. And that kind of informs the rest of Salt. All the Salt states, all the event bus, everything is based off that initial remote execution that Salt provides. This is a brand new server. So if we want to run a salt state, just for those who haven't seen one before, let's do an Apache server here. Okay, so here this is a simple salt state. Apache 2 is the ID declaration, which also will become the name of the package we want to use. We have a package state, and installed is the function that we're going to call. And you notice it's installed, so if the package is already there, it won't do anything. But if it's not, then it'll do the right thing. So let's install this thing. So we'll run the state.sls Apache server. And the amount of time it's going to take here is mostly just apt checking to see if Apache is installed, and then installing it here. So I know for a lot of you this is like the very basics, but I just wanted to kind of give a quick overview of how this works. Yeah, probably does. He mentioned it was probably doing an apt update as well. So that's a simple salt state. Okay, there we go. Done. It took 32 seconds. Installed all the dependencies we can see here. Again, this is all a data structure, so I could have gotten this back in JSON, but you can see here we got the new Apache 2, installed all the dependencies, and gave us information about that. Now at any time, I can run that again, and it will do the same thing. It'll check to see if it's installed, and it already has installed, so it's not going to do anything. I can also, here on the command line, just come here and do and we'll do a package.purge. And when you're on the command line, I'm using the actual execution module, and this is actually going to do this. It's going to remove that package. So there we go, we're done. A friend of mine that runs a bunch of the websites for the major newspapers in Salt Lake was on a train heading home when Heartbleed was released a while back, and he hopped onto the crappy Wi-Fi on the train, ran the little check using this to see which servers were vulnerable to it, got that list, ran the command to fix all of them, and it was done. And the whole process, took 6 seconds to actually do. So you just seriously, that's one of the things literally that got my attention about Salt was just the fast control that you had and the simplicity. Yeah. Okay, so now I want to talk about beacons. So a beacon, like I mentioned before, is a little service you can start on the minion that allows you to watch something. So I'm going to set up a beacon that will watch a specific file for any changes, and when it sees a change in that file, it'll send that event up to the master saying, hey, this file changed. And I'm going to set up another one that will look in a directory and notify any changes there. So if I come in here, so here we have our beacons definition. I'm going to use the iNotify beacon. This does require I think it's Python notify Python module to be installed. So any event, anything that happens to the serve/blah.txt file, Salt will send a message up to the master. For this /serve/testing directory, I'm just going to look for the close write event and send an event up to the master, and we're going to recurse through any directories that are created. We're going to auto add any new files to it, and then the interval says we're going to check every 10 seconds. Okay, so down here, I'm going to start a little listener. So you can see what's happening on the event bus. This is a great way to see what's going on when you're debugging. So let me go into /server directory. Here's that blah.txt. So let's open this thing up and another line. And we'll close that. And then you can see right there, we got a notification that increase that size a little bit. That that file was modified, the change that happened, and the path to the file that happened. Go into that testing directory. So let's create a new file. You can see here in that /serve testing directory, we had our close right. Another right, another close. You can also see there the swap file that Vim created was also modified there. So what could you do with this? Let's say you had some little sysadmin that just will, or some developer that will not stop logging into production server, start editing files, it's always getting in there and modifying things without going through your change management. You could watch your Etsy directory, and anytime there's a change, an event was to be sent to the master, and you could clobber it and say, nope, redo it. We had one of our clients did the same thing with yeah, you can send an alert through PagerDuty, announce it to the world. You can also check for like SSH logins and things like that. So someone logs into a production web front end that they should never do. You could just like log them out and kick them out right off the server immediately if that case. Or you can just notify PagerDuty, notify their boss that someone was misbehaving. Do you have a question? Uh-huh. So spam half the company when somebody modified a file when they shouldn't be. Automated pink slip, I guess? I don't know. Krister. Yeah, so all this does is it sends an event on the event bus. So then you can use an engine or a reactor to do whatever you want to do. So it could be anything. It could be modified. Add something to your CMDB. Oh yeah. Yeah, exactly. So Krister was talking about his security module for checking for file integrity. This could be part of that. You know that files shouldn't be changing at 4 in the morning, and you can get a notification. Then you can log that, however, in whatever monitoring system you have. Depending on the file, maybe do an alert if necessary. Just gives you visibility into that. There are a variety of modules. So if we come here to the beacons section, so we have a disk usage beacon. This one allows you to set thresholds for notifications to be sent. So you can say, hey, if you ever get above 85% on these specific file systems, send us a notification, that type of thing. That notify we saw here, journal D for system D. Same thing with load. You can do your criteria when you want to send a message. People sometimes will use that for load balancing, that type of thing. Certain server gets maxed out. You get above so many, your load gets so high, it lets me spin up another VM to help manage the load. Services .ps for services that are running, there's a whole variety of things. So WTMP is for your logins, that type of thing. So, and we're going to use the Twilio text message today. And let's look at that code for these. You'll see that these are extremely simple. So if I come down to this Twilio thing here, you'll see that we have some documentation, we have some imports, we have a validate function, and then the only requirement you have is that you have a beacon function. You can see here we have our documentation, but this is the entirety of, so that's 30 lines of code, including logging and nice, clean formatting to check for these text messages, as well as to check to see if they have images and things connected to it. So if you had a beacon, you had something else, say you had an application that you wanted to monitor locally on your server, you very easily could create your own beacon to run your checks and send events as needed. Any questions on these beacons or anything? Sure. Yeah. So the question was, could you have a beacon that would watch a log file, and then if there's a specific error, notifies syslog or something like that? You definitely could do that. Okay. So here we have our Twilio account here. I think I exposed my account credentials in the previous went up on the file thing, so I'll change those before we this gets on the internet. So yeah, I do. This is live streamed? Okay, well, we'll be changing that quickly. Again, send the interval. This WTMP, again, is for if I want to check logins. So actually, the first time I gave this talk, I had a guy from Apple in the audience. I didn't know he was from Apple, and I forgot to take it off my server. It's like for the next day and a half, he kept getting text messages that I had to think, so if whenever somebody logged in, it would send a text message to a person, and he texted me back, he's like, hey, could you take me off that server? So those are beacons. And again, you have reactors and engines that can do things with those events. So in the demo that I'm doing today, I'm not actually going to use a reactor or beacon. I'm going to have a little web page that the Salt API is going to expose. And the JavaScript is actually going to bind to the event stream and listen for events from my Twilio account and update the web page when that happens. So just a quick view of this. Friend and coworker Seth House actually wrote this in like 4 minutes for me. He's more of a JavaScript guru than I am. Where are we at? So here we're going to listen to the events on this event source, and then when we're going to update and create a new module or new elements on the web page. So let's see what that looks like. Sorry, I'm losing track here. Okay, so here's our simple web page. Also promoting SaltConf in April. You got to come out. It's going to be awesome. A few of you have been to SaltConf, and it's a good time. A lot of learning, and it's a really fun conference. And is that you? No, it wasn't you. You'd be giggling. Oh, that was Charles in the back. So if you text that number up there, you'll see the text will show up here. If somebody wants to send a, you can send a picture text as well, Please keep it G-rated. This will be on the internet, but somebody wants to send a picture of not of my zipper down, please. So again, what's happening here is my server is running a little beacon, and it's checking every 5 seconds that Twilio account. And when it sees a text, it sends an event on the event bus. And there's a multitude of things we could do there. You know, we could have reactors happening, and you can do many things with each event that comes through. In this example here, we're just listening to that event stream, and on the Twilio ones, oh, that's a big one. Yeah. Here, kitty, kitty. And we're just dumping these to the web page here. So obviously you wouldn't want to do this in production, but maybe you have a monitoring system. You have PagerDuty. You have there's a whole variety of things you might do to monitor things, and you can listen to these events and do things with that. Any questions about this stuff so far? Yeah.
I sort of missed, how did you tell the minion, how did you enable the beacon? How did you tell the minion to start doing this beacon and stop doing this?
Good question. So all I did was added that config file for it, and then restarted the minion service, and it'll process all the beacon definitions and do that. So, yeah. Oh yeah. No, you easily could have that run. You could see that event, take that text of that event, and use command.run from the event loop and do that. Yeah, so obviously all of the security precautions you would take, accepting input from external sources, you would want to do here as well. Yeah. But this kind of thing you could do, if you have like a chat ops type scenario, people want to deploy, from Slack or from IRC or something like that. You can do that with Salt. You could also set it up so they could text something and deploy from Salt. We had a customer that they had this Windows application that would frequently lock up, and we worked with them with their first line tech support, and it was a pretty simple thing to do, but their first line tech support people weren't technical enough to actually log in and restart this thing without screwing things up. It was very difficult. So they kept escalating it to someone who could do it correctly. But it was fairly frequent, and they had a lot of customers that would call in and do it. So we worked with them to add just this red button in their thing. And so the first level tech support could log into the customer's account and say, hey, my thingy, whatever's not working, and hit that button. And that bottom one there scared me when I was a kid. Dave. Yeah, so they just hit this button, and the higher level tech support people never had to bother with that again. They would just hit that, and they gave them the ability to take care of the customers without having to manually go in and fix their problems there. So I was going to text from here as well. I usually would send it from my phone, but I get no bars in here at all. God, which screen am I on? Oh, there we go. So. All right. Any other questions about this here? All right. Is there anything you want? Yeah, go ahead. Sure. Should we get to the microphone?
Hey. Okay. First of all, the message queuing model that Salt uses seems to be quite different from any of the other configuration management systems that I've seen. And it, as I understand it, scales extremely well. What kind of volume can you actually handle in terms of agents that are connecting into that message queuing system for simultaneous processing on large fields of devices?
Really good question. So it's one of those things that kind of depends, but we have people that are using up to 18,000, close to 20,000 minions connected to one master. There are some difficulties when you get to that scale. Sometimes just the flood of data that's flying back. Your NIC can't handle, your operating system can't handle that much data. But there's ways to ameliorate that using Salt Syndic. So you have lower level masters that handle all the cryptography and communication with the minions themselves that then wrap up all the results and send them back up to the higher level master, that type of thing. But places like LinkedIn, I mean, they have, every time I talk to them, it's like they're bigger, but like one point they had like 30,000 servers, and I think they're like 100,000 servers now. Not necessarily all of them running off one Salt master, but a couple of different masters there. So, I mean, it's really common for people to run Salt on like 1 or 2, 3 servers, and then we have a lot that are in the 5 to 8,000 range very comfortably.
Cool. I'm also very interested in network device configuration management. I don't know if there's anything you can speak to about Salt being used in that kind of a context.
Sure. So we have some modules that will reach out to network devices and things. There's a somewhat new feature of Salt called a proxy minion that runs on a regular minion and allows you to take like say a network switch that you can't install the Salt minion on or something like that. With Adobe, we're working with them on I hope I can mention this, but on a module to talk to some server hardware so they can configure the hardware and then bring up the servers and that type of thing. So this proxy minion allows you the proxy minion handles the communication with the device and then allows you to use all of Salt's modules and things like that as if it were a server and that type of thing. You get a small subset of, it's things that make sense on that type of hardware. Yeah. Yeah, you're welcome. I could actually get that to work. It was, emoji were actually breaking it because I was trying to cast everything to a string, and so it was actually breaking so I had to go in and hot patch that code. You're getting close to the line, people. Go ahead.
When I run a command against all my minions, which I don't have that many, like maybe 60 or something, the first time, if it hasn't been run in like a while, the first time a couple of the minions fail to respond, but then like if I hit it again, everything will be fine and happy for the next while as I'm using it. Is that normal? Are they like sleeping minions?
You have to kind of warm them up.
Exactly.
So what happens is, by default, every 24 hours, the Salt master will rotate its encryption key that it uses for the communication on the publish port. And if the minions haven't communicated with the master, anyway, so the next time when that happens, the minions have to, when they connect to the publish port, they can't decrypt the load, and so they'll request a queue refresh. So if that happens like at midnight and your minions haven't talked to the master, at 8 o'clock in the morning when you log in, the first time you run a command, it can throw that off. So there is an option. So that's what happens. So you have to like run like 2 commands to get them all working. Right. There is an option to have the master do a test.ping after the key refresh so that it automatically updates all the keys like that. But that's what's happening there.
Also, is there any kind of testing framework for Salt?
So Salt tests itself internally because states inherently test themselves to an extent. So but we don't have an official framework yet. We're kind of working on ideas on how to do that well. There's a plugin for Test Kitchen that employee of Hewlett Packard wrote, so you can use Test Kitchen, which is a chef tool, to use Salt to test your states and build up a VM with all your states, and then make sure that they're behaving appropriately. Some of the ideas we have with that is to be able to specify success parameters right next to the actual states themselves. So as you build out your states, you can specify, if I spin up a web server, when I access port 80, I should receive this type of text, that type of thing. But it's still kind of in the design stage at this point. And I'm not sure, I'm not sure if that'll even be gotten to this year. So for the moment, that's all we have. So, any other questions? Go. Pardon?
Are you going to be talking about the event Reactor?
Would you like me to? Okay. See, you get immediate audience feedback. It's awesome. Yes, and Utah Dave is my IRC handle. I'm Utah_Dave on Twitter because there's a real estate agent that has Utah Dave. He actually yelled at me on Twitter once, "Who's using my copyrighted nickname or whatever?" I've been Utah Dave. Yeah, nice potato. Actually don't have any on this server. So a reactor is a simple YAML file that sits on your master, and you specify a tag that you want to listen to. And you can use Jinja to look at pieces of the data structure of the events that are coming through and do things with it. Now, when you're creating these, this reactor loop needs to be really, really fast. So you do have access to Jinja, which means you have access to the Salt modules and states and all that kind of thing. So technically, you could run Salt commands and various things from there, but you do not want to do that because you want the reactor matching on these tags really, really fast. Because then when it matches a tag, it'll spin off another process, another worker process to actually run the commands you want. Okay. All right, so here is a reactor that was listening for the Twilio thing. Or actually, no. Actually, this is actually to send an SMS. So in the other demo that I was doing, where every time somebody would log into the server, it would send a message saying so and so logged in. So what would happen? So this first thing here is the ID declaration. So it's just a name I made up for this. It could be anything you want. Local means I'm going to run a Salt execution module, which is Twilio send SMS. Target is going to be Boucha, which was the name of my server. So that's the name of the ID of the server I had. Had to pass in some arguments. My Twilio account, it was just the arbitrary name I'd given, the credentials that's from a Twilio account. And then this thing here, the information from the event that was sent is inside this data structure that's inside of Jinja. So this double brace indicates we're inside of the Jinja environment. So I'm going to get the host name. It says host name logged into, and then the ID of the server, and then the timestamp. I'm wondering if I had that. That's wrong. Seems like it. Yeah. So, yeah, I haven't used this in like a year, so I'm not sure if that should work. But essentially, I'm creating the text that we're going to send in that. Okay. Yeah, so I think this could also just be name. Depends on the data structure. So I would have to look at the data structure that gets sent when someone logs in. So if it was just name, for example, that's essentially the text that we're sending in the data. I'm sorry, in the text we're sending. And then this is the to, so that's my cell phone number, and then this is the from. This is my Twilio number. So what that means is this gets called whenever a specific tag is met. So if we come in here, so in your master config, I don't have one right now, so actually maybe I do. Yeah. So in your master config, you would have something like this. So you have Reactor is the initial config section, and then you have a tag you're going to match on. So in this example, the tag is salt, minion, and then we have star, which is an actual wildcard. So in reality, when a minion would start up, you would see like minion 01 there, where that asterisk is, and then start. So every time the master sees that, it will call first this start.sls, and then this monitor SLS. So in our example here, we would have a reactor, and then we would look for the tag that came up for that login beacon. So you can also send your own events as well. So here's another example. When you get an event with a specific key, you would take that key, delete it, with this execution module. So really, you have the full power stall to do whatever you want. So you can run stage, you can do a whole variety of things. So people use reactors to fix problems that have known solutions that happen regularly. The application developer just won't fix that thing. You can have Salt fix that for you. You can send events, so if something happens, you can have it fix that.
So, in the reactor states, when you have that, you have multiple ID declarations. Do those fire in parallel, or do they fire?
They fire in order. So they start at the top and then move its way down. You can also do things with engines. I haven't actually had a chance to use engines yet, but they allow you to create a Python interface. It's like your own little program, so you can do whatever you want within this little Python program. Let's see, there was... Oh, I was going to show something else. I forgot what it was. Okay. Anyway, that's pretty much it. Yeah.
Is there any kind of rules when you want to use a beacon versus a reactor?
Well, they're more complementary than either or. So a beacon is the thing that's actually checking your file system, and it generates an event. So it's dumb in that it doesn't know what's going to happen. You don't have to configure a beacon to do anything. It just check this thing, check it, and then send an event when the conditions are correct. And then you would use a reactor or an engine to listen for those events and then do something. So that way you kind of get a separation of concerns, because you may not want the beacon running on that server. It could be in a semi-hostile environment or something, or you may not want it to even know what's going on. So it would send an event, and then the master would take care of doing something.
Okay, so the master runs the reactor.
Yeah, master always runs the reactor. Actually, you know what? I think you can run reactors on minions now in standalone mode as well. But in the general case, the master runs the reactors, yeah. So, great question. Okay. Well, that's pretty much the end of my talk. I'm willing to stay and answer questions. Yes? So the question was, when would you use a reactor versus using an engine? I think you would do that when you need more programmatic control of everything that's going on. So when you're using a reactor, it's simple in that you just have, the reactor listens for a tag and then executes this list of SLS files. And then those SLS files are still essentially YAML with some Jinja. And, for more straightforward things, it's pretty easy to go. Sometimes it can be a little obtuse trying to figure out the data structure of the event that came up, and that can be a little tough. Whereas when you write an engine, you're just in Python. So you kind of you get to decide all the flow of that, of what's going on, and you get more programmatic control. Whereas, my experience has been if you're doing a lot of Jinja templating and things like that, I like to keep it at a minimum. If you're doing a whole bunch of it, you're going to get into a big mess and give you a big headache. And so if you were doing complex things, I would look at using an engine. And you'd probably get to define what complex means to you, but that's kind of where I would do that. Yeah, sure. Mm-hmm. Okay. Great question. This question was, he mentioned that there's a lot of configuration management tools out there, and what led to the creation of Salt, and what are the main differences with Salt. So Tom Hatch was the founder of Salt. He worked for, first for a lot of large federal government agencies managing large infrastructures, and also worked for a music startup that also had some large infrastructures. And there are a couple things he just craved as the systems architect was, one, to know what's going on with the servers. They would keep track of servers like in a CMDB or just in a spreadsheet, and it was always out of date, right? Everything should have this version of the software, but you go check in reality and things that happen, and people had updated things, some things auto-updated. You never knew what the current status was. And so he really wanted to be able to have that remote execution. He wanted fast control over his servers. That was kind of some of his main desires there. And he had used basically all the tools that were out there at the time too. And so that's where Salt started, was the really fast remote execution. And that's one of the things that Salt stands out with, is it's really fast remote execution. That's not just bolted on after the fact. It's the core part of what Salt is. Salt is also very pragmatic. So it's very rare. I've done a lot of in the past, the first few years of SaltStack as a company, I did a lot of the professional services, working with big infrastructures, JP Morgan Chase, LinkedIn, various places. And I didn't work on LinkedIn's infrastructure, but worked with training on them and things. And it's rare that you can come in and just be like, everything's Salt. You always have people that are like, well, this little team over here, we're using Chef. We should use Chef to configure our servers, and we're not changing anything. We're not touching it. It's not going to happen. And then there's other teams using another tool, and this other team has their own homegrown Bash, Python, Perl behemoth that they've got going. And You know, it's rare that you can just swap it all out. Salt makes it very easy to use it where it really makes sense for your infrastructure. It's very pluggable, so both from what Salt can do, you know, if Salt doesn't do something you want it to do, you can create a new module and state for it very, very easily. If you have, you know, especially for an execution module, it's very, very basic Python. People that never programmed before, people that have experienced in other languages, you know, the Ruby developers, you know, it's very straightforward to get involved with Python. But also connecting to Salt. So we have a whole bunch of external authentication modules. Some people in this room here have written their own external authentication modules, pulling data, configuration data from their existing CMDBs. You know, Krister, they have their own CMDB that they had written, and it's not going anywhere. That's the source of truth for a lot of what they do. And you just wrote a module, and now Salt pulls data out of their CMDB, and it just fits right in. So it's very easy to tie into everything that you already have existing on your infrastructure. We have Puppet modules and Chef modules that allow you to do Chef solo runs and Puppet runs to manage it. Wikipedia does that. They use Salt to orchestrate all their code releases and all their Puppet runs, but they have like something like, I don't know, last time I talked to them, they had like something like 30,000 lines of Puppet manifests, and they just didn't have the time or really desire to swap all that out. So they use Salt to manage that, to scale their Puppet stuff out. We have Ansible, what do they call their list of servers? Playlists? No. Pardon? Not the playbooks, but their list of servers they have that they run commands against. I'm drawing a blank, but you can use Salt. Salt can use those to run commands on servers. You know, we're very pragmatic about, you know, integrating with, you know, everything that you want. So there's something like 15 or 16 different pluggable interfaces that Salt lets you touch and add on to if you need. One of our big customers here in San Diego, they're spending something like $5 million a year on their previous configuration management software that they were using, and they swapped that out for Salt. And the fact that they could get to the source code and they basically entirely revamped one of the modules. So everything else pretty much worked great for them. There's one module that just wasn't quite doing what they wanted. The fact that they could get on, do a pull request, and make it work right and fix that bug was just fantastic for them. They just, you know, they loved it. So they have the support of SaltStack as a company, but their expertise that they have on staff, sysadmins, and developers can go back into Salt itself. In fact, a lot of times when you're running code with Salt, you're running code that, you know, experts at LinkedIn that are managing 100,000 servers, you know, a lot of the scalability that Salt has was based off of some of our larger users running into things at scale, because, you know, we don't have 100,000 bare metal servers sitting around in a closet there at SaltStack at our headquarters to test against, right? So a lot of the best practices and lessons learned from some of the top people in the world, get all that experience flows back into Salt. Like the Reactor, so there's people here in the room that I was working with them, and we were working on re-imaging. So they had a tool that could re-image a server and just completely, you know, put a whole new OS and change it from like an application server to a database server or backwards, or vice versa. So we're working on automating that. Then it occurred to us that, like, well, maybe what happens if something goes crazy and suddenly it's thinking it wants to re-image, you know, 400 database servers? You know, that could cause a major problem. So we added in a queuing system. I'm not sure if we actually got that fully implemented there, but added in a queuing system that would allow you to add things to a queue. So if there was like 5 that need to be re-imaged, okay, that's normal. But if suddenly there was like 400, you could say stop and, you know, do that in an orderly way. And so, I don't know, I could go on and on, but there's really, you know, I've done professional services with some incredibly talented people, and I've never used a tool that was so flexible. There's like, I've hardly ever run into a situation where Salt just could not do something. That's correct. So even in our enterprise software, Salt itself is Apache 2.0, completely open source. And for a couple of years, we actually provided packages specifically for our enterprise customers that we supported directly. And we're moving to a framework instead that they'll basically use the same packages, but we're building a tool called ROS and a web GUI associated with that sits on top of your masters that will allow you to, at this really large scale, to keep all that data and scale out to the tens and tens and tens of thousands of servers and view that at a pretty massive scale. So that allows us to provide value for our enterprise customers at these difficult large scale situations, but also have everything else open source. So if you contribute code back to Salt, it is all Apache 2.0. So you're not going to contribute code back to Salt and suddenly it's only in the enterprise version. I mean, it's all open source and it's available for use. That being said, we do now have support offerings for just open source. So if you have 500 servers and you would like to have support, but you're just running straight open source, we actually support that now. So you can have support contracts for that as well. So yeah, for a long time we didn't. We required you to do enterprise to get support, but we don't at this point. Yeah.
Can you speak briefly about the choice of crossover between writing a formula versus standard everything goes in file?
So the question was the difference between writing a formula and having everything be like in your top file or I guess in your file roots. So Salt formula, if you go to, we have a GitHub organization that we keep all of our Salt formulas in. And there's, I don't know, I think we're into the hundreds, I think, now at this point. So Salt formula is kind of a generalized, kind of a best practices way of doing something. So at this point, they're pretty much they're all community supported. We do provide some support to that, but our community really is rallied around and worked on those. And it's so basically you can just clone that Git repo, or you can use GitFS on that Git repo. And so like most of them straight out of the box will give you an installation of, let's say, MySQL or something with some sane defaults. And then they're set up to allow you to pass in variables to configure that simply through like the pillar system, that type of thing. So anytime you have like a generalized thing, Salt formulas are a good way to look at that. So say you have a MySQL expert on staff and she has everything just tuned just right. Well, other people in your organization can use her Salt formula to do the right thing without having to be an expert with MySQL, for example. And so that would be kind of where, whereas maybe somebody else has, a light HTTP state that they just use, and so they would just stick that on their file roots on their master, and no one else really cares about it. And so they wouldn't necessarily make that like a public, or at least public within your organization. The good thing about using the ones on online as well that we have is that, again, you're using something that people have already gone through the pain of experience to get going. So, obviously you need to test them to make sure they work according to your needs, but sometimes it's a good way to get started on something complicated without having to do it all yourself. That's essentially what a Salt formula is. Yeah.
Can you recommend your best book or the best book on writing Salt?
There are 3 out right now. Actually, no, there's 4. They're all pretty good. So there's 2 by Joseph Hall, who's one of the original 4 co-founders or original engineers of Salt. One's like kind of like a getting started, Salt basics, and then he just released another one that's more advanced use cases. I haven't read the second one yet, but that just released. So it's Joseph Hall. I'm not sure what the name of the book is. Yeah, there's another great one that's written by Colton Myers. And then a former engineer from LinkedIn also wrote one as well. Drawing a blank on the name of that, but there's like 3 or 4 books out, and yeah, we have some Salt Airs. We haven't done a lot of video tutorials yet. We do provide Salt training, both in our office. We can do it in your office, and we also do it remotely. So we have a remote video conferencing system that works really well for training as well. So those are really, and it's actually a really great training. Our founder was actually a trainer for Red Hat for a long time, and so his the training class. If you go to saltstack.com, they'll have some things on training. We have a guy in the back here that would love to talk to you about that as well. This guy in the green jacket. And I know I'm very biased, but it's actually one of the better trainings I've ever been a part of. I mean, you'll come out of it with a really good overview of everything Salt can do, as well as getting your hands dirty, doing all the configurations, and even extending Salt to an extent too. So you really come out with it's a great boost. In fact, when I was doing professional services, I would basically force them to do a training the first week we did stuff, because it just helped for them to like know what we were doing, because they had the training already. So it's a really good time. So. All right, I think we're out of time. I can stay around for a few minutes afterwards, but thanks everybody for coming. I appreciate it.